Good afternoon everyone. Here we are discussing optimality test for transportation problem. Actually, using northwest corner rule, least cost entry method and then VAM method, we are solving initial basic feasible solution. And the improved solution of initial basic feasible solution is called optimal solution, which is the second stage of the solution of a transportation problem. We have already discussed for optimality test we have two methods. One is stepping stone method and another is modified distribution method. According to our syllabus, modified distribution method we will apply for finding out the optimality test. This method is also known as UV method, where the dual variable u and v has been used to provide a minimum cost solution to the transportation problem. Here I am taking one example. Find the optimum transportation schedule and minimum total cost of transportation of the following problem. This is the problem given where this is the cost matrix, these are the supply value and these are the demand value. First we have to test if the transportation is balanced or not. After testing that, since it is not given in question that have to use to find initial basic feasible solution by northwest corner rule or least cost entry method, then we are applying only one method, which is called VAM method, which gives us the best accuracy of the problem. That's why we are applying VAM method. And after applying, here I am not showing the VAM method, but you have to show. After applying VAM method, we have the following initial basic feasible solution, which can be given in the table. That means we need the allocations. Okay, after allocations we have in the transportation table, we must show that if the problem solution is degenerate or non-degenerate. Since the value of total number of allocations is equal to m plus n minus 1 equals to 5, the solution is non-degenerate. So this is the first stage. In second stage, we are applying MODI method. For applying MODI method, we have to determine UI and VJ values for the basic cells or occupied cells. The cells which have allocations only, that cells are called basic cells and occupied cell. Here we make a table where the table has the cost value and corresponding allocations, and I have no supply value given here and no BJ values or demand values are given here. Here we have some variable we have to use corresponding to first row. We are using the variable u1 according to MODI method. For the second row we have used the variable u2, third row we are using variable u3. Similarly, first column v1 corresponding to second column variable used v2 and corresponding to third column variable is used v3. If your row and columns are more than 3 by 3, it will be increased as u1, u2, u3, u4, u5 and so on. Similarly, v1, v2, v3, v4 and so on. To find out the values of u's and v's, we are using this equation ui plus vj equals to cij for the basic cells or occupied cells. But before we start this equation, since both the values are unknown, first we have to choose one value of u equals to 0. Normally we are used according to row. What is the condition? Condition is that in which row the maximum number of allocations is there, that in that row the u value should be taken equal to 0. If here the allocations is 2, in second row allocation is 1, in the third row allocation is 2. So maximum number of allocations are in the first row and third row. So we can choose u1 equals to 0 or u3 equals to 0. I am choosing u3 equals to 0. If in row we are not getting maximum number of allocations, that is will be lesser than column in column, so you may choose column, but preferably row has been chosen for maximum number of allocation, and in that row corresponding u value should be taken equals to 0. As we have to take u3 equals to 0, so we are use calculation from this row of allocation cells. Allocation cell is 3 1 and 3 2. So we are using this equation C32 equals to u3 plus v2. C32 equals to u3 plus v2. Put the values of C32, that is the cost value 8, equals to u3, we have taken 0 plus v2, so we are getting the value of v2. Similarly, for the cell C31, u3 plus v1, that is equals to cost is 7, u3 0 plus v1 equals to 7. In this way we go for next other values C12, C13 and C23, C12, C13, C23. Since 1 2 u1 plus v2, 1 3 u1 plus v3, 2 3 u2 plus v3, and according to that you put the values and we are getting all ui and vj values. After getting all these values, we should put the values in this way. So after that, next step is that we have to find out the net evaluation. Net evaluation or opportunity cost, which is notation is delta ij, which can be solved for unoccupied cells or non-basic cells. Which are called non-occupied cells, unoccupied cells or non-basic cells. These cells are called where the allocations are not met. That cells are called unoccupied cells or non-basic cells. So how many cells are there? 1 2 3 4. And what are the locations? 1 1, 2 1, 2 2 and 3 3. So 1 1, 2 1, 2 2, 3 3. And what is the formula? Formula is Cij minus in bracket ui plus vj. So for del 1 1 we need two equations, C11 minus u1 plus v1. Already we have find the values of u and v, so we have put all these values, and C11 is the cost of unoccupied cells, so we are putting the cost. Actually the total in net evaluation, it is dependent that the solution is what type of optimal. That's why we have to find out the net evaluation, which is denoted by del ij. So here 4 net evaluations are there. In that way we have to calculate, and all del ij's are greater than 0. After calculating all these, we make one table where all the allocations are there, where all the allocations are given in this way, and the net evaluations are given in a circle for the unoccupied cells, and these are the u values and these are the v values. This is the total calculations for the optimality. After getting all del ij greater than 0, we conclude that the given transportation has optimum solution, and this is the minimum transportation cost. But how we should conclude? For that we have to use one note. Note is that net evaluation implies opportunity cost, that is equals to del ij for non-basic cell. We have to check the sign of del ij, which will decide the type of the optimal solution. What is the first condition? If all del ij greater than 0 implies the solution is optimal and unique. Here we have got all del ij greater than 0. All del ij are greater than 0, that is positive. Then it will decide the solution is obviously optimal, and unique means the allocations we have, this allocation is a unique type of allocation. That means the allocations have not maybe in another cells. These cells are only one cell where the allocations are met. If anyone choose for calculation the one cell and another cell up in first or in second row or column, that means it may be gives us another basic feasible solution. But if the solution is unique, we are getting only one type of solution. That means it must be the allocations or positions, that is the only one's position. There is no another positions of this initial basic feasible solutions. But for second conditions, if all del ij greater than 0 with at least one del ij equals to 0, that means if in these three are greater than 0 and this one is equals to 0, then solution is optimal but not unique. Not unique means there is another type of allocations may be. Here we have the allocation in 5 cells. If one del ij equals to 0, that means there is an option that another type of allocations may be. Maybe this allocation may be here, or this allocation may be here, like that. Okay. So this will decide the solution obviously optimal but not unique. There is more than one basic feasible solution exists. But if at least one del ij less than 0, that means all are positive but one must be negative. If there is this type of situation, then the solution must not be optimal, and for that we have to use another method which is called loop formation method. After doing loop formation, we get a new basic feasible solution. And if again in that new basic feasible solution we have these three conditions will apply, and if first is satisfied, then we get this number of type of optimality. If second one satisfied, then this number of optimality, and if it will again go for third one is not optimal, then again we have to use loop formation method. Thank you.